Hi guys, right. So question one, the Hylo method. And of course, I think what's important to always remember is context. What are we trying to do here? We are using a slightly rough sort of hand method, if you could almost put it that way, because we have algebraic methods that we can use, um, assuming that there is a trend, if you like, in this data. It's not necessarily true. So if we sort of say we have total costs on the y-axis, the independent axis, and we have on the x-axis the units, we're sort of arguing that, listen, um, we can assume a trend with the figures that we have. So we are literally plotting all these figures, if you like, and their corresponding costs on this trend. So if we did that, you would see here that we'll start off at this 11. This is the lowest one, isn't it? 11,150. So I'm arguing that at 11,150 units, the cost is total cost, forgive me, is 60,000. Now remember that I have a variable cost here. Sorry, I have a fixed cost, the actual fixed cost that um, is associated with this trend sitting over here, and I'm going to call that fixed cost A. Right. Um, so changing my pen color back, what I then have is I could actually plot all of these along this chart. So the next one, of course, here is 11, 7, 11, 766, and that takes me to, again, like I say, this is not necessarily the case. What you actually might actually have, if you plotted this, you might notice that this might actually be somewhere here. It might be. I'm just to give you the reality of what's going on, and then you would have here 63,080. I'm just going to clean this, give me space. Right, just write it here again. Total costs. Total costs on the y-axis, and then the next one. But I could keep going. But the point is that I'm really looking for the point of lowest activity, which was this one, and the point of highest activity, which is this one. So I'm going to go all the way here to 13,100 and assume and make this assumption that somehow, thankfully, both of these, well, not both of these, I'm going to create a situation where I will connect both the lowest point and the highest point to give me a trend so that this equation can work. But then assuming what will most likely happen is that all the other points and coordinates will lie around that trend, right? So these are the other actual points lying around that trend. So you have 13,100 there. And that 13,100 corresponds to a cost of 69,750. Right, so what does the Hylo method say? It's really saying that, listen, for every unit that you produce, the argument here is if this is a straight line, of course, and this is linear, what we are saying is that for every unit that we make, we experience a cost, if you like, a variable cost, because this is a variable, right? So we could actually literally find what that variable cost is. All we have to do is just compare, if you like, the total costs are between two units, right? Because if I go from 11,150 to 11,151, and the cost goes from 60,000 to, I don't know, 60,005, well, I can tell that the variable cost must be 5. So in effect, that's what we're ultimately trying to do here, but we don't have it for one, we have it for, if you like, this sort of distance. I'm saying when the units increase from 11,150 all the way to 13,100, the costs increase from 60,000 all the way up to 69,750. So this is what we refer to as the Hylo method. I find the difference between those movements, between these areas here. And so 69,750 minus 60,000 is 9,750. And I'm going to divide that by the 13,100 minus 11,150, and I get 1,950. Divide the two, 9,750 divided by 1,950, and that's a variable cost. Actually, that's funny. That's worked out at £5. So my variable cost per unit is £5. So what I now need to do is I now need to come back and I can literally plug that. I mean, I know I should pick something, either this one or this one, because they lie on that line. It's this line that's going to give me this fixed cost. Anything lying on this line will give me this fixed cost here. So the argument here is, well, I know what for example, I'll pick this one. I know that the total cost of making the total cost, remember, the total cost is equal to total variable fixed cost, of course, plus total variable cost. Well, let's look at it. If I want to make, I know the total cost of making 11,150 units is 60,000. I don't know what the fixed cost is, no problem, but I know that I need £5 to make every one of those units, and I'm making 11,150 units. So the total variable cost is this, plus this fixed cost will give me 60 grand. So I guess the simple question is, what is 5 times 11,150? And you have 55,750. So 55,750 plus the fixed costs are equal to 60,000, and therefore the fixed costs are 60,000 minus the 55,750, and the answer is 4,250. And that's where we're going. So that's, and just apply this. This is the principle. Yeah, so awesome. So you can, of course, as you know how I do these things, I won't do the next one that looks identical. You can now take this and apply that for your own practice. Great stuff.